Welcome to the lecture on complex analysis, probability and statistical method. In my previous lecture, I discussed about what is joint probability distribution and also how to find the expectation of the random variable x, random variable y and xy, and also about variance, standard deviations and also covariance of xy and the correlation coefficient of xy with respect to the joint probability distribution. In this lecture, I am going to discuss briefly about the problems related to the joint probability distribution. Example number 1, a joint probability distribution is given by the following table. So the values of the random variable x is given by 1, 3 and the corresponding y is given by -3, 2, 1. The value of P11 is 0.1, P12 is 0.2, P13 is 0.2, P21 is 0.3, P22 is 0.1, P23 is 0.1. So we have to estimate the value of covariance of x comma y and also verify that x and y are statistically independent variables. So to show that x and y are statistically independent variables, we must have the condition that covariance of x and y must be equal to 0 or the expectation of xy must be equal to expectation of x into expectation of y. So now here to find the values of the expectation of x, expectation of y and expectation of xy, we must have the marginal probability distribution. So how to compute the marginal probability distribution is nothing but first we have to find the marginal distribution of x and y by adding all the respective row entries and the respective column entries of the given joint probability distribution table. Suppose that I want to estimate the values of f of x1. So at the value of x1, x is equal to 1, add all this complete value to get the value of f of x is equal to 1. Similarly, at x is equal to 3, add this complete row to get the value of the next value. And similarly in the column wise, at y is equal to -3, add this column. At y is equal to 2, add this column elements. At y is equal to 4, add this column element. So we'll get the marginal distribution like this. So this at x is equal to 1, I got this value. At x is equal to 3, I got this value. And summing these two values, the value must be equal to 1, we have to get it. So it is obviously satisfied here. 0.5 plus 0.5 will be equal to 1. Similarly, at y is equal to -3, I got 0.4. At y is equal to 2, I got 0.3. At y is equal to 4, I got 0.3. Adding this, I got the value will be equal to 1. So these two are the marginal distribution with respect to the given joint distribution table. So now from this easily we can estimate the values of expectation of x, expectation of y and expectation of xy. So mu x will be equal to expectation of x. The formula is summation x into f of x. So multiply each x value with f of x value plus this value with this value, that is 1 into 0.5 plus 3 into 0.5 will get the value of expectation of x. So it is 2, I got it. Similarly, e of y is given by multiplying each y value with g of y value and adding it. So -3 into 0.4 plus 2 into 0.3 plus 4 into 0.3 will be equal to 0.6, we got it. Summation of xy. So it is given by summation with respect to x, summation with respect to y into random variables x into y, p of x comma y. So this can be computed from the joint distribution table. For example, like this. 1 into -3 into 0.1 plus 1 into 2 into 0.2 plus 1 into 4 into 0.2 plus 3 into -3 into 0.3 plus 3 into 2 into 0.1 plus 3 into 4 into 0.1. So like this only we have to estimate the values of expectation of x comma x into y. So on doing summation, I got the value is 0. I got the value is 0. So here only we can note that e of xy value will not be equal to e of x into e of y. So obviously here the random variables x and y are not statistically independent. So now I can estimate the value of covariance of x comma y. So covariance of x comma y is given by expectation of xy minus expectation of x into expectation of y is equal to -1.2. So this is a required solution for the given problem. One more example, the joint probability function of two discrete random variables x and y is given by the function small f of I is equal to c into 2x plus y. So where x and y can assume all the integral values such that 0 less than or equal to x less than or equal to 2. I mean the range of x will be 0 to 2 and the range of y will be 0 to 3 here. And f of x comma y will be 0 otherwise. Apart from this condition, the value of f of x comma y will be 0 here. So find the values of the constant c here. I mean this constant c we have to find it, and p of x is equal to 2 comma y is equal to 1 and p of x is greater than or equal to 3, y is less than or equal to 2, we have to find it. So to estimate the value of c, we must have the condition that f of x comma y should be positive for c is positive and the summation of f of xy should be equal to 1, we have to get it. So from this condition only I am going to estimate the values of the c. So to prove this, the first thing is we have to make the joint distribution table. So given f of x comma y is given by c into 2x plus y for the range of 0 less than or equal to x less than or equal to 2 comma 0 less than or equal to y less than or equal to 3, and the function will be equal to 0 otherwise. And also given that x and y are discrete random variables, therefore the joint probability distribution table is as follows. So first let me define the values of x and y. So I am taking x is equal to 0, 1, 2 according from the range of x. Similarly I am taking y also from the range of y, that is 0 to 3, 0, 1, 2, 3 I am taking. So now if I replace x is equal to 0, y is equal to 0 the function, I will get 0. If I replace x is equal to 0, y is equal to 1, I will get c. If I replace x is equal to 0, y is equal to 2, I will get 2c. If I replace x is equal to 0, y is equal to 3, I will get 3c. If I replace x is equal to 1, y is equal to 1, I will get 3c. If I replace x is equal to 1, y is equal to 2, I will get 4c. If I replace x is equal to 1, y is equal to 3, I will get 5c. If I replace x is equal to 2, y is equal to 0, I will get 4c. If I replace x is equal to 2, y is equal to 1, 5c. If I replace x is equal to 2, y is equal to 2, I will get 6c. If I replace x is equal to 2, y is equal to 3, I will get 7c. So this all values are obtained from the given function f of x comma y is equal to c of 2x plus y with respect to the given random variable range. So now we know that always the summation of all these elements should be equal to 1. So now I am going to frame the marginal distribution. So adding all these complete rows and these complete columns, some value I will get it. If I equate that value should be equal to 1, so the value of the random variable I will get it there. So adding that values here, 0 plus 2c, c plus 2c plus 3c, again 2c plus 3c plus 4c plus 5c plus 4c plus 5c plus 6c plus 7c. Adding all these values, the value will be equal to 1. I can take it. So I am taking the formula, the double summation of p of x comma y will be equal to 1. I mean summing all the values. So adding all the values I got, I am equating it as 1. So it will be equal to 42c, I will get it. So 42c is equal to 1 in the sense c is equal to 1 by 42, I will get it. So now I am going to estimate the value of p of x is equal to 2, p of y is equal to 1. So p of x is equal to 2, y is equal to 1 means this value, that is 5c. X is equal to 2, y is equal to 1, so 5c. So 5 into 1 by 42, it will be 5 by 42, I will get it. Third one, p of x is greater than or equal to 1, y is less than or equal to 2. So take the values of x greater than or equal to 1 means we have to include p of x is equal to 1 and 2, and y is less than or equal to 2 means take the values till 0, 1, 2. So I can take the values like 1, 0, p of 1, 0 I can take it, p of 1, 1, p of 1, 2 I can take it, again p of 2, 0 plus p of 2, 1, p of 2, 2 I can take it, like this. P of 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So take all the values with respect to these probabilities, add it, I'll get 24c. So c will be 1 by 42, I got 24 by 42, it will be equal to 4 by 7. One more example, a pair of coin tossed thrice. The random variables x and y are defined as follows. X will be equal to 0 or x is equal to 1 according as head or tail occurs in the first toss. And it means that the value of x will be 0 if the toss 1 is head, the value of x will be equal to 1 if the toss 1 is tail. And y denotes the total number of heads. So if 3 heads are there means the value of y will be 3. If 2 heads means the value of y will be 2. Find the probability distribution of x and y. and the joint distribution of x and y, covariance of x and y. So first let me define the joint distribution table and also the distributions of x as well as y. So first, so on tossing a coin 3 times, so the possible outcomes will be head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, 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 I will get it. So total I am having 8 possible outcomes here. So now the marginal distribution of these probabilities are, first thing is we have to define the range of x and y. So according to the values of x, if the toss 1 is head, I can take x is equal to 0 here, x is equal to 0, x is equal to 0, x is equal to 0. Since the toss 1 is head, I can give the value of x will be equal to 0 here. And here x is equal to 1, since the toss 1 is tail. And x is equal to 1, x is equal to 1, x is equal to 1. Next I am coming to y value. So y is nothing but number of heads. So here I can give y is equal to 3, y is equal to 2, y is equal to 2, y is equal to 1, y is equal to 2, y is equal to 1, y is equal to 1, y is equal to 0. So the range of x will be here 0, 1 and the range of y will be 0, 1, 2, 3 I can take it. So now with respect to this I am going to define the marginal probability distribution. So now I want to find the value of f of x. So for toss 1, if the toss 1 is head, I am having the value of x equal to 0. For this all starting 4 values, I am having the value of x is equal to 0. Now f of x value with respect to this 0 will be 4 outcomes are there. 4 outcomes out of 8 outcomes, it will be equal to 1 by 2. Similarly, for x is equal to 1 value, I am having 4 outcomes here. So 4 outcomes out of 8 outcomes, it will be equal to 1 by 2. Similarly, g of y. So g of y is y is equal to 0. I mean all 3 tails. So only 1 outcome out of 8, that is 1 by 8. Next is 1 head means I am having 1, 2, 3. 3 outcomes out of 8, that is 3 by 8. For head is equal to 2. If 2 heads are there means I am having 1, 2, 3. 3 out of 8 outcomes, that is 3 by 8. 3 heads, only 1 outcome out of 8, that is 1 by 8. So these are required marginal distributions with respect to the random variables x and y. So now I am going to frame the joint probability distribution with respect to x and y. So how to frame this? It is given by, first one is x is equal to 0, y is equal to 0. I mean the toss 1 is head and no heads. So it is highly impossible actually. Here we can see here. So actually x is equal to 0 in the sense the toss 1 must be head here. Y is equal to 0 means no heads at all. So it is highly impossible case. I can take it as 0. Next is toss 1 is head, 1 head. So it is only 1 outcome is there. That is 1 by 8. Again toss 1 is head, 2 heads at all. 2 heads should be there. So it is actually 2 outcomes are there. That is 2 by 8. It will be equal to 1 by 4. So from this one, toss 1 should be head with 2 heads at all. 1 head, 2 heads. So 2 outcomes are there. So 2 by 8 it will be equal to 1 by 4. Similarly, toss 1 must be head, 3 heads. It is 1 by 8. So adding this I will get f of x, that is 1 by 2. Again, toss 1 must be tail and then no heads. So it is 1 outcome, it is 1 by 8. So toss 1 must be tail with 1 head. It is also I am having 2 outcomes, that is 2 by 8. Toss 1 must be tail with 2 heads, 1 by 8. Toss 1 must be tail, 3 heads should be there. It is highly impossible case. With toss 1 is tail and with the 3 heads is highly impossible. I can put 0 here. So adding all these rows, I am getting 1 by 2. Same thing here also I am getting 1 by 2 here. Adding columns I am getting 1 by 8, 3 by 8, 3 by 8, 1 by 8. Summing it, I am getting the value 1 here. So it is a joint distribution table is satisfied here. So now from this one I am going to estimate the values of covariance. So first we have to estimate the expectation of x. So we know how to estimate the expectation of x. It is given by summation x into f of x will be equal to 0 into 1 by 2 plus 1 into 1 by 2. It will be equal to 1 by 2. So E of y will be given by summation of y g of y. So it will be given by 3 by 2. Next is summation of xy. So summation of xy is given by it can be estimated by using the joint distribution table, adding all the elements by multiplying x value, y value with p of x value for each element. So we'll get the value 1 by 2. So now we got the value of E of x, E of y, E of xy. We can estimate the value of covariance. So covariance of xy is given by expectation of xy minus E of x into E of y. It will be equal to 1 by 2 minus 3 by 4. Answer is minus 1 by 4. Thank you.